In this video, we're going to look for parametric equations of a line through the point 0, 1, 2 that's perpendicular to the line x equals 1 plus t, y equals 1 minus t, and z equals 2t, and it also has to intersect the line. So we know that the plane that contains the point 0, 1, 2 and is perpendicular to the line will be given by the equation x minus y minus 1 plus 2 times z minus 2 is equal to 0. The reason why we know that is that if I want a plane that's perpendicular to the line, the vector that I use for the direction for the line, I can use as my normal direction for the plane. Because if I use that direction vector for the line, remember that direction vector is pointing parallel to the line. If I use that for the normal direction for the plane, then my plane is guaranteed to be perpendicular to my line. So if I use the direction vector for the line as the normal vector for my plane, the plane will be perpendicular to the line. Now I just need to make sure that that plane goes through the point that I want. So I just use the point 0, 1, 2, since that's what we were given as the point that's supposed to be on the plane, to plug into my scalar form of the equation of a plane. We can rearrange that equation to be x minus y plus 2z equals 3. So this equation, this plane, will intersect the line when I plug in the values, or plug in the x coordinate, y coordinate, z coordinate in to the plane and get a true statement. So I get 1 plus t minus 1 minus t plus 2 times 2t equals 3. Rearrange the left-hand side, we get 6t equals 3, or t is equal to 1/2. What that tells me is that the point 3 has 1/2 1, which I get by plugging the 1/2 back into the line, is on both the line and the plane. Remember, we're trying to find an equation of a line, so I need 2 points that are on the line so that I can find an appropriate direction vector. So the point 0, 1, 2 is on the line. The point 3, 1/2, 1 is on the line. If I do terminal minus initial, I will get 3/2. That should be a comma, a negative 1/2, and then negative 1. Will be the direction vector for the line that I'm interested in. So if I want parametric equations then for the line that goes through 0, 1, 2 and is perpendicular to a given line, I use this point and this vector for my direction vector to get 3/2 s, a negative 1/2 s plus 1, and a negative 1s plus 2. So 1 minus negative 1/2 s and 2 minus s as my parametric equations of the line. So here's a picture of what we're talking about here. Here's the point of intersection that we found. Here would be our first line that has an equation of a direction vector of 1, negative 1, 2, which was on the first line here. So remember, we had a direction vector of 1, negative 1, 2. So here's your x-axis, here's your y-axis, here's your z-axis. So this has to be the 1, negative 1, 2. The other one has a direction vector of 3/2, negative 1/2, negative 1. And we can see 3/2, negative 1/2, negative 1 for your direction vector in this way.